All right, so why are you here today? What are you looking forward to hearing about? Thundercat.
Hello.
I know Thundercat. I was a kid then too. Okay.
Microservice architecture.
Yes, that's the topic. And why are you here? Curious. Okay.
Sounded better than the other sessions.
Huh?
Sounded better than the other sessions.
Oh, I'm the least of the evils. Thank you. That's a good start.
I think it's probably a good architectural, and potentially a good architectural choice for us because we've got a lot of services that we're trying to deliver, and we've packaged them up into big services that deliver a lot of features, and we find problems in that in terms of they then become more monolithic services that are hard to maintain in you've got a number of different scrum teams who run on it, and it's hard because multiple teams are then dipping into the same services, which is poor. So hopefully this sort of architectural is moving forward.
Yeah, I'm finding it quite interesting myself. So actually, when it gets really time to officially start, I'll officially start, but not quite there yet. We just have a person who probably wrote code before I wrote code. Hi, Tom. So what year did you start writing code?
If you count plug boards.
Yes, I will cut plug boards.
1958.
Okay, so he's going to be beat by 10 years. This is a scary dude. Definitely want to listen to Tom talk about this stuff because it's kind of scary. I think it even beats Ron Jeffries. Ron Jeffries has me by 6 years, I think. He's around 62 or 63 when he started writing code or something like that.
Young kid.
Yeah, just a child, yeah. Cool. Well, actually, it wasn't before I was born, but it was definitely before I started writing code. Cool. It's kind of a full audience. We might as well get close to getting started. So my name is Fred George. As you know, I've been writing code a long time. I am old. Not as old as he is, thank goodness. We have somebody else in the audience to say I was older. I still write code. I was speaking at a conference in Kiev over the weekend, but before that, before I flew out, I was writing code that day I flew out from California. So I still like it. It's still kind of my fun thing to do. As such, this is a presentation about things that I've actually done. So these are my experiences I'm talking about. So I'm not going to sit here and talk about generalized principles to some extent unless I think I've generalized them for my own use. So these are things I've done. I currently work in a startup called Outpace. I joined them at the end of April. It's a very interesting little startup because we basically have McKinsey consultants, and McKinsey being the high-end consulting arm of the world, to consulting CEOs, along with programmers of like talent. And we're doing systems for large companies right now. And I find it very interesting to walk into a CEO's office and start the sales process of the CEO, which is kind of new from my experiences. But it's really interesting when you walk into the CIO's office and he gets out of your way. It's kind of like, hey, what can I do for you? It's kind of fun now to write code in that environment. A lot of the stuff also comes from some experience I had at Mail Online. Those of you from London, of course, know what Mail Online is. It's our tabloid news. If you don't know what Kim Kardashian is wearing today, this is where you go. But they're doing some very interesting things in microservices. I worked there for about eight or 9 months before I headed off to California. And a lot of the stuff actually was germinated in experiences at Ford Internet Group, a company up in Camden here. I worked for them for about 4 years. Back when there were 35 people, I think I left, there were still about 450 people left there, so they grew quite from 35 to 450 in my little tenure there. Lots and lots of brands in there. You probably know USwitch if you're in the area. So this story kind of starts in when I was working on a project, and it was kind of a layered architecture. And I kind of like to use this as the model for a layered architecture because it kind of reminds me of all the layered architecture pictures I used to draw. It's Stonehenge, of course. I was not the architect for Stonehenge, and I don't think Tom was either. Close, but it's a layered architecture. So you'll typically refer to layered architectures like this, where you have these cross services and layers like this. It's a Stonehenge architecture. So I was in India at the time working on this project, and it was a fairly interesting project. But it was, the year was 2004. It was 1 million lines of J2E code. At one point in time, it was the largest Sun-certified J2E application in the world. And it started really well. It has a great history behind it. take my mouse with me. In fact, Martin Fowler was an early consultant to ThoughtWorks on this project. I'm going to keep wandering around both sides to make sure I block everybody equally. And then he joined ThoughtWorks after that. And he wrote a book called Patterns of Enterprise Application Architecture, a really great book about applications and really complex applications. And a lot of this book is based upon this application and his experiences with it. So it had a really good start, really great fundamental structure behind it. But here's what I found when I got to India in 2004 to keep working on this project, because we were making significant enhancement to it. 1 million lines of code, 2,000 automated tests. 70% acceptance test passing was considered good. And it was a different 70% every day. It was still considered good. And I'm scratching my head and says, really? The bug database has 1,000 entries in it. There's 1,000 things people have found wrong with this that they haven't fixed yet. Not sure they're still there anymore. We still want to make changes to it, and no new tests were being added. And we ThoughtWorks at the time, we consider ourselves an Agile shop. We think we're really good at this stuff, and this was just this was very strange to me. Needless to say, we were able to do that. It was a struggle. We got some more tests written. We actually went to 8,000 tests, which is still missing 20,000 tests that we needed to run. We did make a significant number of enhancements to it, restructured it somewhat. It was successfully being enhanced. But I walked away with sort of an impression. In fact, one of my colleagues that I brought to India with me to work on this sort of had this interesting comment. He says, this million lines of code, he really thought it was about 100,000 lines of code trying to get out. That the other 900,000 is completely wasted in some way. That you could write this whole thing over again in much, much, much smaller, if you really took your head to it. And the more I looked at it, the more he was absolutely right. It wasn't that big of an application compared to how big it actually was. So I took that to heart. So that's kind of my last experience in that. So then we were evolving. Now I'm working in a project in a Chinese bank in China. So I'm in Shanghai. We're trying to put a services architecture in place. I had a chance to work with Jim Weber, who was working with ThoughtWorks at the time and also an author of a lot of SOA books at the time. I think he's moved on to become the chief scientist of Neo4j, as I recall, last time I saw him. And basically, the problem they were faced with is they have all the things the banks want to do. They want to do insurance, they want to do loan processing, you want to check your balances, you want to give you cash, mortgages, and the like. And you want to do that, obviously, when you're talking to the tellers at the desk. But you also want to do that from every other device. And then actually, at that point, I was impressed in China because they really did have a concept of ATMs and smartphones being able to do all these banking transactions. Things that my US banks that I was used to could not still do. But they wanted basically to have all these guys be able to access all the workstations. And we were brought in to sort of propose to the bank that this is how you want it to work. You want to be able to glue these things together accordingly. So, with Jim Weber's help in particular, we subscribed to an idea of using a pub sub. Wow, great reflection off that bus. That applications would subscribe to this. So basically, you had a concept here, some clients coming in, so our client is available to you. Not sure what the channel is, don't worry about the channel. But I have a client in front of me. What do you want to do? And all these guys would bid for things they want to do with him. Oh, offer him a mortgage. Make sure he's paid off his credit card. Give him some cash. All the things you want to do when you have a customer in front of you. Let them bid for that. And then the device would decide which of these things are appropriate to put in front of the person at the time. Could be if I'm sitting at a desk, it may be just a little green light flashing saying, make sure that you tell them they're overdue on their credit card, or it's a really great mortgage opportunity, let's see if you can sell a mortgage to them. Versus a smartphone, which may have a different presentation of it. But the idea is to separate the presentation of these offers from the things that wanted to put the offers in front of them. The client said no thank you. They still wanted to, actually they wanted to buy a package of software from Citibank because obviously Western banks are smart and Chinese banks are stupid, so therefore we should buy Western software. Regardless of the fact that Citibank software was like 30 years old at the time, you didn't really want that software. So nice idea, but I kind of walked away going back to what Jeff Bay said, and basically now began to feel in 2005 that if given that opportunity in China again, I would rewrite it as a set of smaller services. I'd find these 20 fundamental things we're trying to do, write little services around them that keep the coupling down so I can isolate these pieces from each other and talk to them. So I'm beginning to get a feeling that I restructured that Stonehenge in a completely different way if faced with that same issue again. All right, roll the clock a little more forward. Same year, but now I'm back in the US. I was brought back to the US because we wanted to work with this company. It's a medical systems industry. They make lots of devices. And so they have lots of devices, X-ray machines, MRIs, and the like, laboratory support. And this company that sells this hardware also understands that if you want to really sell this hardware, you really want to sell the hospital system. Because if they have your system in place and your hardware fits well into your system, it's easy to make the software sales with the hardware sales. So it all bundles together. And there's all these people that really want the information from these various buses. You have patients that care about it, doctors, critical care nurses, of course, well, the accountants. The accountants love to know that you've used their equipment because they can charge you for its use. And so we decided we'd put this little, have this concept that these guys would publish what they know into an information bus. The information bus would then have various people subscribing to it to listen to what's going on. And a little bit of the same sort of thing we try to do with the bank in China. Various sort of things that were generating information, various people have interested in that information. And we looked at this information nuggets a little bit, the idea of publishing this little nugget of information around. And we decided that, you kind of just wanted to publish summaries on the bus. Don't give me the raw data. If you're taking an X-ray of somebody, what I really want to know is you took an X-ray, right? And, or a CAT scan in this case. And I really want to know what the result was. Is it good? Is it bad? Is it something I should, is it critical? Just give me the summary of what I should do with this. And also we had the idea that this information is only good for a certain amount of time. Hey, maybe this is your blood type. It's probably good for a long time. But if it's information like this information is only relevant. It should be only hanging around to be subscribed to for a limited amount of time. Then it should kind of fall off the bus because you don't want people reading old information. So that idea was also rejected by this company. They actually they had a Java system. They wouldn't rewrite, actually it was written in C++. They wouldn't rewrite in Java, but they didn't want to test the UI at all. So basically they were just taking their same architecture and carrying it over. Needless to say, it was not successful, but they didn't like this idea either. When I put this presentation together, I got a real sense for how unsuccessful I am in my career, which is, why are you listening to me? So in 2005, a company right close to the same facility, they were doing investment services. This is one of these funds that invest various monies. They wanted a prototype for a new system architecture. My colleague Jeff Bay, the same guy who did work in India with me, decided he would take that challenge up. I ran away from this guy screaming because they were not competent. They were not going to make any changes. But Jeff decided he'd take it on anyway. And he came up with some really interesting principles when he's writing the services in this environment. Things that I thought were completely wrong when he said them. But it was one of those things that when he said them, I can't really tell you why they were wrong. His first principle is it's okay to run more than one version at the same time in the system. And I'm like, what? You're going to run which service are you going to wind up using, version 1 or version 2? He says, run them both. Find the one you want to use. And it's like, I don't want to take down version 1 if somebody's using it, so keep it up. I was like, but Jeff, you got version 2. Shouldn't you move to using it? He said, no, don't bother doing that. The other thing he says is deployment meant deploying only one service. That's it. That's all you can deploy is one service. You can't deploy 2 of them and call it a deployment. It's only one at a time. So if you really want to use that server, you need to deploy the new version of the server. Then you can deploy the client. But you have to think about it in those terms. And what he did was he got this company that was used to releasing once every 3-4 months. He had them actually deploying 3 times a day under this environment. So he kind of had broken the thing. And the key behind these 2 concepts that he came up with was, if it's old code and it uses the old version, I'm not impacting it by putting a new version of it out there as long as they still bind to the old version. There's no risk associated with that. If they want to move over at some point and use a newer version, that's fine. Just do a deployment to do that. And that's a very safe little deployment. Either it works or it doesn't work. It's easy to roll it back if it doesn't work. So the risk associated with deploying new software was completely sort of obliterated by these 2 principles that fundamentally felt wrong to me growing up in the Stonehenge age, but for what turned out to be very insightful. So I took this note away from there. It actually was only a prototype, somewhat a successful prototype, but it still wasn't an actual running system at this point. So Jeff Bay and I got together again. Now we're working in one of the big automobile manufacturers in Detroit. And they want to do some batch processing for replacement parts that need to go into cars. And there's parts in some cars that need to be replaced. And the problem was the client there are many variations of how you find cars. You know, you find a car by, it comes into your service bay and you recognize it has an out-of-date part. It could be you have a record of the client from somewhere else. It could be the client calls you up and asks why it's not working. I mean, lots of different reasons, but we always have different information coming in trying to help identify the car. But the key is I have to get all the information I need in order to put the service order in place to make this happen. So the challenge was collect enough information to build a complete service order so we can push it into the system and get the repair scheduled. The vendor said between 15 and 18 months to actually make modifications to the existing system to do this. The business felt that was completely unacceptable. In fact, they thought they would almost be out of business if they had to wait that long to make these sort of changes. There was much more urgency to that need. Of course, one of my lessons in consulting is when people are urgent, they will let you do crazy things. And so I love those sorts of environments. So basically, we went in there and said, we have this new idea how we want to do this. And I call this the pinball model, just to really make it scary. And the idea is to basically take these little packets of information and kind of refine it. So actually, I'm not going to have really entities in my databases. I'm going to try to create this order on the fly in a packet. And if I start out with address information, I kind of want to fill in all the rest of the stuff. Maybe I have a date and the name, date the car was bought and who bought it. Perhaps I have a vehicle identification number, which is really good. But I need to fill in the rest of the information. So we came up with an idea that says, let's take this little packet and let's kind of drop it into into the pinball machine. And we built these little services that basically said, if you give me the VIN and give me this, I can give you a new value. I can fill in a value for you. But if you haven't got the VIN, maybe you can get the VIN if you had a name and some other information. And well, if you haven't got the name, give me the name, if you give me your address, I can tell you what your name probably is. So I wrote these little tiny services. Most of these services tended to be centered around database connections. And so if you came in here with an address, I say, well, I need a VIN. Well, if you haven't got the VIN, let's go over here. Okay, so you send the packet over here. I need your name. Oh, you haven't got a name. Okay, well, send you over here then, because this guy gets names. Oh, address, fine. Drop the name in. Okay, then we dropped it right in back from the top, started all over again. And it said, oh, need a VIN, haven't got a VIN. Need a name, oh, got a name. Now we just need this thing. Do you have that? Otherwise, go somewhere else and get it. So a little pinball, dancing around, trying to get itself filled in. It turned out that we took the database, there were tons and tons of tables, and we carved it up into little pieces. And we carved it up saying, this little service is the only guy that's going to touch these tables. And other tables over here would only be touched by this guy, and these tables would be touched by this guy. And there was no cheating allowed. You couldn't go through and reach through somebody else's tables. We wanted to keep that decoupled. And it turns out the most interesting table actually to sort of own is a join table, where you're putting two pieces of information together. So it turned out that was where the interesting services wound up being. We delivered the system in 9 weeks. 18 months, 9 weeks. Needless to say, the customer was quite happy with this. So it was an innovative design. Again, desperate customer. This actually kind of revolutionized a lot of the processing in this particular division of the company. They went Agile crazy after that because of some of the stuff we worked out. Now, we ran into some, so I had some new observations after this, because it turns out these services were really, really tiny. And when I was running around Jim Weber in China trying to talk to Jim about services, I kept saying, Jim, what should be a boundary around a service? How big should a service be? Never really got a good answer. So I kind of fell back on my object modeling roots, and I have some history in object modeling, and I kind of said, well, maybe a service is like a class. That maybe you should have one job as small as possible and still do something interesting. But I only want to publish conclusions. I don't want to give you my raw data. Giving you my raw data is like violating encapsulation. And so I said, let's do that way. And in that system we developed in 9 weeks, these services we were writing were getting really tiny. 100 lines of code was the typical size of these services. And it was still doing something interesting. And again, it worked really well. I have a small talk background, which is where that comes from. And encapsulation in my world also meant taking the database and segregating it. So there is no cheating at the database level either. I don't want you to reach through the database level and grab something out of somebody else's table. Because actually, you know, if you treat the database that way, it's just one giant global data structure. And giant global data structures make programs very, very hard to change. And so I really wanted to keep the database broken up. And everybody was publishing conclusions, just like we talked about in the Chinese example. Publish your conclusions. Don't publish your raw data on the database. If you publish your raw data, then maybe you don't have any value. You should be providing a conclusion. You should be working with some sort of processing. Now, we ran into some problems, though, having to get this. And one is, it was really hard to tell what's going on in the middle of the system. You know, sometimes it looked like the little pinballs would keep going round and round and round and round, and they wouldn't come out. And sometimes it was like, where's the ball? It's like, where'd it go? We can't find it. It's not going around anywhere. It's just missing. Fell on the floor, tilted. I don't know what. So it turned out we had lost packets, had cycles. And so we really refined our concept of what it means to monitor a system like this, how much important logging is and monitoring. We let the little packets start counting themselves. We kept the little breadcrumbs in there. If you came back to the same service you visited before, it's probably not a good sign. So that sort of thing. So we got a little better at that. The really interesting thing was the team that we had, and we had a very bright team, they didn't really have an understanding of how to break a problem up this way. They're used to building Stonehenges. And so when you say, break up into small services, everybody does their own little piece, carve the database up, they're like, what? You know, how do I do that? How do I even think and decompose a problem that way? I was kind of surprised by that, but it turned out that getting the team to think about the problem this way was really difficult. And after the first release of this product, I moved to London to take an assignment here. Release 2, the services got a little larger and stuff like that because it was easier to think about and change them that way rather than think about how to carve out a new service. But it did actually win an award at a ThoughtWorks Tech Day, but actually for being a really bad idea. So actually, I got a T-shirt from I think one of the geek sites as my award for this dubious award. So I would say maybe we delivered it, but if it's delivered and called a bad idea by ThoughtWorks, maybe it's not such a success after all. I always claimed it's just where they weren't smart enough. That was my comeback to Jeff Bay. He said, you know, Jeff Bay was the one that put this Tech Day thing together. He said it was a bad idea. You'll hear more about Jeff Bay soon. But I walked away with a new theory behind my thing. So no longer are we talking about 1 million lines of code or 100,000 trying to get out, or these even 25K services. Now I'm beginning to feel that there's 200, maybe much, much smaller services there. That the granularity of services I was thinking about originally was way too coarse. The services could be much, much, much smaller than this. It's to be productive. So now I'm working for Forward here in London. And we wanted to put a system together that monitored AdWords, because one of our first business we were in was internet advertising. And if you know about anything about internet advertising, just Google, you put ads out there, you bid for the ads have, you know, you get placements for the ads, you get all sorts of feedback from Google about how good your ad is, how much you had to pay for the ad, and et cetera. And we proposed that we actually want to do this pub/sub model again. Actually, I wanted to use Lynda spaces. There's a Lynda space implementation built into Ruby called Rinda spaces. It's a nice way to sort. It's kind of a bus-like structure at some level. You publish into it, and everybody can subscribe to it. I definitely wanted to segregate the database. So we're going to have small databases, each one supporting the individual services. So I was going to break the database up from day one, so that every little service would have its own little database. We define little user agents for the various users of the system, so they can have a guide point to publish to. And we'd automate all this stuff. We went offshore for the implementation. A bit of a problem because, again, I ran into the issue that the offshore programmers, and it was a very good programming team, didn't understand how to design this way. So we had a few early snafus, but the CTO, who happened to be a former Oracle executive, that was a bad sign, said, oh, if you just have one big database, you wouldn't have this issue, and it kind of killed it. So another rejection. But the idea stuck within the development team, and next year they came back and started building something called Cardwall, which was an agile card space. But in the background, they decided we want to give notices to the people using this Cardwall that things are going on. And so they built a little microservice implementation of the covers. And it was extremely successful. So what it would do is the concept of one service has only one role to do. For example, there'd be a service there that goes and pulls a specific Google report down and puts it into a non-relational store. End of service. It'd be another service that would wake up and say, oh, let's take this Google report, run one type of analysis on it. Something interesting is about, let's post that to the user. Maybe there's another type of analysis you want to run. Different service. Maybe the same report, same target user, different service, because we're running a different algorithm, separate it out. And they built that system that way. And so we constantly started learning to use it. Oh, by the way, you know, you look at this aspect of your Google campaign, or here's another thing about the campaign that's going wrong, or here's some more keywords you should be looking at. So we're beginning to make constant recommendations for these little services constantly running. And we actually migrated all this stuff to the Hadoop cluster because it got to be lots and lots of services running. That was a massively deliberate success. In fact, so successful, shortly after this, I think the Forward was up to 55 employees. That year, we made 55 million pounds of revenue with 55 employees. It was lucrative, the support the system had. So being able to do this in an automated fashion was a game changer for our industry. So new observations, revelations to this point. One of the things that happened was these services became disposable. Almost no service had a life of more than 4 or 5 months. And then somebody would change it. And oftentimes, because they were so small, they would just rewrite it. It wouldn't matter picking the code up, trying to understand it, and rewrite it. It was a matter of just throw it away and start again. They were always loosely coupled. We try to make sure the services were kept isolated. We isolate themselves either by sharing non-relational stores, you know, key value pairs like that, or RESTful interfaces. There's still some knowledge that there was a specific flow through the system, so it's a bit flow coupled, but the data coupling is quite independent. And we had a lot of unit tests. Actually, we almost wrote no unit test anymore. It's 100 lines of code. It's kind of, what could possibly go wrong? Well, things do go wrong, and so we kind of had the idea that these services themselves, if they can't do their job, they need to raise their hand. So if I wake up, look for that Google report, and it's not there, I need to alert. Now, it's probably not my fault. It's not my job to get the Google report there. But at least I'm alerting so somebody can look into the problem and find out what's going wrong. And because the services were really small, it was quite easy to debug these sort of systems. So when this guy raises his hand and says, I'm missing my Google report, we look at the non-relational store, lo and behold, he's right, it's not there. Or maybe it's there, but it's in a new format because Google changed their mind about their formats today. But it's pretty easy to diagnose such systems, and we would hop on that. So rather than running unit tests, we kind of made these services a little smarter so they were kind of self-testing all the time. We stopped writing acceptance tests. In fact, I think it's been at least 5 years since I've seen an acceptance test in my world. But we did have active monitoring in our system. So one of the things we hooked to the system was something that was showing the business metrics, the KPIs all the time. So from a deployment perspective, the programmers were always looking at the KPIs. If they deploy something new and the KPIs went down, it must have been a bad idea. Now, it could also be we had another tsunami in Japan. So we're not really sure. So you take the code back off. If it stays down, it's not my fault. If it goes back up, it sounds like it's my fault. But that feedback would come back sometimes within 30 minutes after deploying code. They could get KPI business metrics about that code. So that was a key part of that. And it turned out the side effect of this that was completely unexpected is these services are so small, they're loosely coupled, I can write this service in any language I choose. It doesn't have to be the same language for all services. So some services are written in Ruby, some services are written in Clojure, some are written in Node. And we didn't care. And you may pick up a service and it's in Node, and you decide this, I need to fix it, I need to change it, make a new version of it. I might write my version in Ruby, not a big deal. Nobody cares. By the way, the side effect of this is programmers got a chance to play with a lot of new technology, keeps them excited, and again, motivated programmers, they do really nice jobs. So some side effects from that. So it was successful. We took that same architecture and forward and applied it to some other places. And we went to very much the concept of an event-oriented stream of stuff. And that's driven a little bit. By the way, the current USwitch site is written in this new technology. So if you go to USwitch, look at it. It's all being built with microservices now. By the way, it's built in Ruby for a little bit for the front end. Clojure is actually doing the key processing, picking your best energy plan. All the traffic monitoring is done with Node.js. So a whole different strange technology stack behind there as well. So So there's two things that are driving this from our side. First of all, we started reading a bit some about the Silicon Valley companies. In particular, this book was influential to one of our designers. And it basically talks about the Google philosophy of systems. And in their world, it's all about events. There's no concept of really about entities around there. It's all about events. So when you go to a Google, do a Google search, that's an event. If you click on one of the entries, that's an event. If you go to the second page of entries, that's an event. If they do a spelling suggestion, you take that suggestion, that's an event. If they suggest a spelling change for you and you don't take it, that's also an event. They record all that stuff. Now, they record it regardless of whether there's going to be a use for it or not. The philosophy here is don't worry about who's going to use it. If you do something interesting, record it. Its usefulness may come out in the future. This has paid huge dividends for Google. We decided we want to take that philosophy as well. Just, if you do something interesting, record it. So not only these little services, not only are they monitoring themselves, but once they make an interesting decision, they should publish the fact that I made an interesting decision as well. The other big influencer we had was that basically all data is real data. That there's not just a current state of the world. That every point in time is interesting. If this was your address at one point in time, that is real data. If you changed your address, fine, you got a new address. That still was your address back then. Don't change that. That's there. And that's inspired basically by this movement toward closure in list-based languages. And the fact that basically storage is getting to be relatively commodity and quite inexpensive. There is no reason to destroy data except for how you tend to work with it. So we took that to heart as well, and we built a system out of that. So we basically went back to the Uswitch site and we said, okay, there's a whole cloud of signals we're getting about things going on in the system. When people interact with us at Uswitch, we're finding out all sorts of things about people. We just need to create a set of events and just put them into a stream. So you get things like, oh, you gave me your postal code because you're asking what your energy plan is in that region. Maybe you gave me your name, or you open an email that we sent you, or you had a request to visit a certain page. These are just events. We started recording all these things. And we began to see patterns that we didn't expect to see. For example, you just take these sort of things together and you look at that and say, well, that's kind of like an entity at some level, but I'm not trying to pull it out separately and put it in a database and call this a customer or such. Because it could be that all of a sudden your postal address changes. So I get a postal address that's associated with some of this that's different than this postal address. Well, it turned out that created what we call an opportunity. Because what it meant was, if this has changed and you got the same email address, you may have moved. You may need an energy company. You'd be a good guy to send something to this email address saying, it looks like you just moved. Would you like to consider another plan? Or maybe the email address changed and the postal address didn't. Well, maybe somebody moved into where we used to have a customer and somebody else new has moved in there. Maybe we should go to approach them and say, hey, would you be interested in changing energy providers? So we began to ferret out little opportunities just by looking at this stream of events and running little services monitoring these sorts of changes. And we were able to market very aggressively to these customers, which were real customers having a real need. And that's a much more efficient type of marketing structure. So we had lots of people creating these little things. We had lots of apps, we had services, we had third-party hooks, webhooks, all sorts of things generating this information. We had all sorts of guys actually analyzing this information. I think I will twist this a little to the side. We use R. R is a really ugly language if you haven't seen it before, but the stats guys love it. But it can do all sorts of amazing statistical things. We recorded everything that was going on in the system. We just stuffed it into Hive. We had active monitoring going on for things going on, troubles happening and the like. And by the way, even our server statistics about load balance and stuff like that were all being pumped into the same bus. So if you want to see a stream of events about what's going on, load traffic's going really high, these servers are getting loaded, this would trigger an event that says, let's allocate some more virtual machines. We could write all that as a service. We put it on a Kafka bus. I'll talk more about Kafka in a minute, but Kafka is actually the message bus that's used by LinkedIn. LinkedIn uses this as their underlying thing because they care about events. If you're ever on LinkedIn, you know it's all about events. I know you, you know me, I recommend you, I looked up your name. It's all about a stream of events. And what LinkedIn does is they took that fundamental bus they had and they open sourced it. It's now in a proposed Apache project. And the nice thing about this bus it'll handle about 250,000 messages a second. It's a screaming fast bus. We will take advantage of that later. And it's free. So we use it for lots of things. We started writing these little applications to pull information off the network. We drew this really interesting diagram that's kind of fun to look at, especially after you've had a few beers. But basically what it's showing in the various colors is people coming on a site at one point and migrate to, say, look at credit cards somewhere else. So who's, people coming on a site for one purpose and moving to another using another purpose. But sometimes it's not bidirectional. But this sort of shows where customers interested in one of our services at USwitch would then look at a different service and when they weren't doing that. And this led us to sort of putting better links between where people were trying to migrate and where things were very poor. We need to look at how we make that link stronger so we can cross-sell from, say, a guy switching their broadband provider, get them back into an energy switching perhaps proposal. How do we wire that together on a site? But this is actually what was happening with our real customers. So we use this to basically tune our site. And we can also draw maps like crazy about here's various user journeys through the site. This is like 20 lines of code hooked to an R system. And I draw these maps saying here's how people migrate through our site. These are sort of experiments that are very, very easy to run when everything is on an event bus. 20, 30 lines of code, you have something very interesting to look at. All right, so one of my findings from this point is I had a theory because I like to keep my world neat. If you watch me eat food, I keep my food very organized and very geometric patterns as I eat it. And so in my world, architecture and process, they're really orthogonal concepts. They don't really relate to each other. That I can do waterfall, and with Agile, I can do waterfall. I can do architecture with waterfall. I can do architecture. It's really the process doesn't matter with the architecture. And it turned out, with my experiences here, that was just really not true. So my world is not as happy as I wanted it to be. And here's kind of what happened at Forward after we did this project. These were sort of the Agile best practices that we wound up not using. And a lot of that was due purely to the architectures we were using. For example, all these things, concept of unit tests. I'm running a unit test for 100 lines of code. Why? You can't write 100 lines of code correctly? Why are you a programmer? Well, I want the unit test so that I can when I make a change to it, it's correct. It's 100 lines of code. You can't understand it? So then we'd be desk checking this stuff and just deploy it. Desk check and deploy. Desk check and deploy. Acceptance testing, yeah, we killed that one in favor of this active monitoring of business KPIs. Concept of refactoring and patterns. These are things you do in order to keep a Stonehenge proper, keep the layers clean. You want to have these things for the Stonehenge applications. But if you're not building a Stonehenge, these things are not so important. Even things like duplicate code. We do duplicate code all the time. Hey, that service pulls a Google report up. I want to pull a Google report up. Copy it. Don't try to tease it out into the common component and put it into a library and make sure everybody's using it. No, not worth the effort. Just copy and move on. Get it out there and see what happens. Continuous integration was kind of interesting because we went to a much more aggressive thing. So, of course, the Forward guys, the programmers have their own website. One of the things they do is keep track of their GitHub stats. This actually was pulled quite a while ago now. But they were saying, they published this on their own GitHub stats. And in the last 7 days, 53 developers made 882 commits, resulting in 652 deploys. In a 40-hour work week, that means they were deploying something live into production, new, every 3.5 minutes. Literally go from the developer workstation and deploy. No integration environment, no acceptance testing environment, no operations involvement, just deploy it, see what happens. That fast reaction time drove the business cycle. And again, this is a result of a microservice architecture where I'm modifying 100 lines of code. It's not that hard. And if I get it wrong, I've only probably broken a little bit of the system. The rest of the system's still working fine. The risk is minimized. All right, so conclusions at this point would be, this would be my list of things I recommend for microservices. First of all, they're really small. You think they're small? They're really, really small. As small as possible and still do something interesting. Still draw some conclusion that they're publishing. You really want to loosely couple them, including coupling, to try to decouple the flow. So they're just starting at forward when I last checked with them to sort of decouple the flow connection amongst them. More bus sort of publishing. Multiple versions are actually acceptable. I would say even encouraged. They encourage multiple versions out there. Don't take an old version down. If you're running on Amazon virtual machines and you got a service up there that's still running that nobody's actually calling on anymore, so what? Well, I should take it down and try to save the money. It's probably costing you 10 quid a month. Is it worth 10 quid a month to even try to find it? Probably not. Just leave it up there. If one day it crashes on its own, nobody figures it out, then so what? So literally, we didn't go around trying to make sure that we got all the old services down. It's one of those things that's just not worth it. It's not worth it for the money. We do want these services to be monitoring themselves. So we like this idea that, every service says, if I can't do my job, I need to raise my hand. That's a fundamental concept behind it. And also, they want to publish everything that's interesting. In other words, do the Google thing. Regardless of who needs it. If you do something interesting, publish about it. And the whole concept of application in this world kind of dissolves. I can't really point to this as the application. Where do you draw the boundary saying here's an application? It's a much more complex system than that. So the whole concept of applications and stuff like that seem to go to the wind. And also, to some degree, I would call it a living software system that you think about these individual services, they're dying all the time. These individual services don't last more than 4 or 5 months before they're replaced. But the overall system had been running 3 or 4 years at that point in time when I left, and it's still running. So it's kind of like the human body in some way. It's like our cells, our original cells, they're all gone, but we're still me. We're still being replenished. And so the system kept getting smarter and smarter and smarter, but it was the same system at some level. But the individual parts, almost none of those guys are around. It's all new parts. Again, quick deployments, we talked about that. One thing people say, well, this is a really complex system. Well, kind of so was that Stonehenge system. I mean, the one that only had 70% of acceptance tests running. Complexity has not been mitigated at all by this, but it's not been made worse either. And we killed the acceptance test by basically refocusing on dynamically looking at the KPIs on the fly. Literally, if you're in a system, and Forward only went into businesses where we had rapid feedback. And with a rapid feedback system, I'd rather have the feedback from real customers and real environments really working than to run some acceptance tests in a sterile environment without any of the external world services involved with it. Almost all the systems we're building now, and that I tend to build, have dependencies on external services to provide some of the information. It's really hard to make sure those things fail the right way in an acceptance test environment. You should assume they're going to fail in the real world and try it. There's a trading firm in Chicago that does this same sort of stuff. And what they do is they deploy extremely rapidly because it's day traders. You don't want to sit there and run big month-long acceptance tests. You want to get the new code out there so you can make some money off of it. And basically what they do is they pump little transactions through the system constantly. Now let's spend $10, buy some IBM. Let's sell that IBM stock. Good. Let's do it again. Let's do it again. And they keep doing this all day long, losing a little bit of money on every transaction. They don't care. They want to make sure that when they hit it with $100,000, it will go through clean. And so they constantly deploy into that environment. If those little $10 transactions start failing, it's something they did. Let's fix it quickly. But they're constantly monitoring their system that way by pumping real transactions through it. And therefore, they're also testing all their external dependencies. So really, acceptance tests on a static system, not very interesting anymore. Dynamically monitoring your system to make sure it's still working, very good idea. And we talked about the impact to the processes. And finally, almost the most important point, it's really hard for your developers to get their head around this model. So you got to give them some time to play with it, get used to the concept. But once they get used to it, they get really, really fast at it. Now in Forward, once we get over the learning curve, it's just a matter of adding guys into an existing team that does this. They pick it up pretty quickly. They sit down the first day, they help write a service. Second day, they help write another service. They're beginning to understand how small these things are. And then they're beginning to understand the bigger picture of how the system works as they touch more and more services to the point where they can work on their own quite easily. But they're kind of productive from the first day, just sitting down and writing code with a colleague. All right, so this is all very nice, and Forward's kind of a special case. I mean, they made a lot of money. It's a startup. How about this stuff working in a much more staid environment? So I took the opportunity to join the Mail Online. Those that don't know the mail online, actually it dates back to 1890 is when I think it was founded. They've been doing tabloid news since the beginning. This is not a new thing for them. Kim Kardashian wasn't around in 1890, but they were equivalent. What absolutely was. And if you don't know, of course, Kim Kardashian, being aside, the head of the mail online is Lord Rothermere, the fourth Lord Rothermere of his name, conservative organization at some level. So we went into the conservative organization, and we basically have put in new technology to do the new mail online. So the new mail online site that when you see is actually generated by new code that was put in place this year by this team. There are a couple of attendees at this conference from the mail online. If you can pigeonhole and find them, absolutely talk to them about this because it's some very cool stuff they've been doing. So they're using two different languages. Node.js is one of the environments they're doing it, and they're doing it microservices in Node.js. So, and they're writing very, very tiny services. I thought I wrote tiny services before. These guys are writing a dozen lines of code as a service, and they deploy it. And that's kind of consistent with Node.js if you're in that environment. They're all about little libraries. Every library does exactly one thing. You grab the libraries you need to do the things you need to do. That whole philosophy is very consistent with Node.js. But they're writing lots and lots of small services, and the services are really tiny. The other thing they did is they also use Clojure. Clojure is actually driving the main part of the site, basically painting the screens. And they wrote 4,000 lines of Clojure code that displaced a legacy 150,000 lines of Java code. They talked about that at the conference a couple weeks ago. That's a stunning number, even in my mind, about the power of some of these languages. Now, interestingly enough, the Clojure is not running in microservices. It's kind of a bit of a monolith, but 4,000 not being much of a monolith, but nevertheless, it's not broken down into maybe 2 or 3 services overall. So not microservices at all. And I don't really know much about that because, again, not my experience, but maybe functional programming style is not necessarily consistent with microservices. Maybe microservices is more consistent with more of the structure or functional or sort of object-oriented thinking about problems where data is isolated. Because basically, list-based services are all about shared data. So I don't know about the list-based languages and microservices yet. All right, so currently I'm at Outpace. I'm in California now at a startup. We are doing microservices as well. I kind of began to describe this stuff, even at the mail, when I was at the Mail Online, is sort of, here's my sort of analogy of what's going on. I call it rapids, rivers, and ponds. And this is my original sketch of it on my iPad sitting on an airplane. And the idea basically is the concept of a rapid, where basically it's a rapids because it's just every piece of data is being thrown into that bus. It doesn't matter what it is, you throw it into the same bus. Now you may want to pull off some themes associated with that. You know, pull off some topics, whatever, and you pull these off of the rapids and put them into a river so that this river only has things that are sort of very related events to each other. But the original event stream is every event you could possibly think of sitting in the same bus. And then this concept of ponds, which is people sort of listening to rivers, perhaps rapids, but basically trying to keep the current state of something going on. Think about your relational databases or your reporting databases being here that says, I want to keep the current state of what's going on. I call it a pond because that data is relatively static. It's not flowing nicely like the rivers. Here's a picture of what it looks like. It could be a historic picture. It could be the current state, whatever the current state means. But that's the idea of the ponds. So this is kind of the sort of metaphor we're trying to build around. Architecturally, how this fits together is the following. So we have a high-performance bus. We put it at its core. And that's for that we decided we would pick up the Kafka bus. So right now our bus of choice is Kafka because it does take a quarter of a million messages a second. That allows us to be pretty sloppy with our messages. We can do that Google thing and pump messages to it constantly, not necessarily worrying about whether this bus can hold it or not. It can hold it. It's 250,000 messages a second. When you look a little harder, though, when they say 250,000, what they mean 250,000 messages in and out. So when a message comes in and a message goes out, that counts 2. It's like, really? That sounds like one message to me. No, the way they count is counts as 2. So if it goes in once, comes out 10 times, that's like 11 messages. Oh. By the way, all the bus architectures count this way. When you say messages per second, you think, oh, I can pump that many messages into it. You can pump it in there, but you can't get them back out. You can only get half of them out if you pump it half the space. So they kind of cheat on their statistics a little bit. But they cheat enough that I'm a little worried about that. So what I'm going to do is I'm going to use my Kafka for my rapid. I want everybody to post messages into Kafka. And I want the message to be relatively small, publish your conclusions. But in order to sort of make it a little more clever, what I'm going to do then is I'm going to hang some 0MQs off of this. And maybe we may write our own version of this, but 0MQ is like the name says. It's not a queuing system, but it allows you to do fan out and locking and some other mechanisms. We're going to use it for its little fan out capability. And I think 0MQ binds into like 40 different languages. So you can include that library in 40 different places. What I want to do is I want to limit the number of people listening to Kafka to as few as possible so I can save as much Kafka bandwidth for things I want to pump into it. So I'm going to put little 0MQs that are pulling the messages off of Kafka and deciding whether I want to keep the message or not. So these become my rivers. So they'll pull the messages off. They'll say, oh, does it have the following traits in the message? If so, keep it and send it on to everybody who cares. Otherwise, just throw it away. Don't worry about it. Not my problem. It's not one of my messages. And I'm going to put lots of those guys on the bus. Probably I'm thinking right now, I think my latest count is probably about 10 of these guys hanging off the bus. So some may be looking at very complex message structures. It is certainly possible to chain them together. You're looking for certain messages. You're looking for a subset of those messages. You can chain them together this way. And what I'm doing is I'm saving my Kafka bandwidth, as well as I'm saving the internet bandwidth it takes to get messages in here. Because our limit in Kafka sometimes is going to be how much data can I get to the bus through the internet. A lot of the stuff we run the same backplane, so I got 50 gigabytes or so on the backplane to use for message bandwidth. But I can hang my 0MQs off of this. And this becomes my high-performance bus. I might, in an early release, if I don't need as much power, I could drop a RabbitMQ in here or some other message technology. But fundamentally, I want a message technology in here that can hold lots of data. So a service, when it hooks in, is going to hook in to a 0MQ to get a message it cares about, process it. But if it has something to say, it needs to say it back to the rapids. Pump it back into the rapids. So everything gets pumped back into the Kafka, not back through the 0MQ. 0MQ is just for filtering and making sure I don't chew up too much Kafka bandwidth with lots of services sitting on it. We have a system we're developing right now. It looks like we'll probably have 100 different services running in this system. I don't want 100 guys hanging on this Kafka bus. I'd rather hang 10 off and segregate them. And that gives me 10 times the bandwidth of Kafka left over. So we like that arithmetic. By the way, these are, of course, their own little microservices running their own little virtual machines. Now, the services themselves using this bus, we want to take the approach of asynchronicity. So one of the things I don't like is this synchronous flow of services, that they have to go in a certain order. Because when one of those services goes down, you kind of broke it. I like to degrade. I don't want to break. I just want to degrade when things like that happen. So we kind of have an architecture that says, here's how services kind of work with the bus. So a service will publish, it says, I have a need. I would like to know something. Perhaps I'm sitting there as this MRI device sitting there saying, oh, I have some interesting information, I want to publish it to the bus. We have other services that care about this particular need. They like to satisfy this need. They have solutions for this particular problem you're offering. And they will publish their solutions back to the bus. To which the original service is subscribing to all of these solutions, and his job is choose the best offer you like. Choose several if you want to. But you decide which one of these guys you like best. Going back to the banking example in China, this could be somebody sitting down at an ATM. And the ATM says, oh, I got a customer in front of me, I know who he is. And this guy says, oh, I got some credit card offers I want to give. Here's a couple offers for him. And this guy says, oh, he owes us a mortgage payment. And those will come back to here. The ATM will look at these things and say, what's the most important one to show to the customer? Maybe I'll choose the mortgage payments due. I'll pop that up on his screen and say, oh, would you like to pay your mortgage right now because it's overdue? Again, the channel making the choice. Yes?
I'm wondering, how does this service which first requested the need or published the need to the bus, how does it know that all services providing solutions have answered?
It doesn't know. It doesn't know. When he publishes need to the bus, he has no idea anybody's going to ever respond. He chooses the one, he waits a while and he picks the one he's got best at that point. And it may get better if he waits a little longer. One of the things we're doing with this service, in fact, is we work one of these services up in our new system into two parts. One that receives these offers and puts them into a Redis database, and one that's sitting there waiting for demands from the customers. So depending upon your channel, sometimes you have a chance to push things to your channel. If you're running HTML5 with WebSockets, I can push new information to you on your web page as it's coming in. If you're an older browser, you only have to do it on a pull, so your next page refresh, I may give you a different set of things because I have better answers. It all depends upon your channel. If we're supporting call centers as one of our other channels. So here's a call center, so once we know the customer's up there, we're accumulating information. And as soon as we have an idea, we put a little green light in front of the customer, in front of the sales agent, and she can decide when she wants to look at this or not. And the longer she waits, the better the answer we're going to have there. But once we have an answer, we show the little light. So again, we're talking about, we're not guaranteeing necessarily the best answer. If you waited 5 minutes, you'll get a better answer. But if you need an answer today, we'll service that by hitting you here. Excuse me, then we hit the screen. Now, the coupling we do have is we do have to agree on our message formats. We're using JSON packets. We have to agree what our JSON structures look like in order to have this sort of communication. But the only agreement has to be only across these guys, and that's a pretty generic sort of structure. Again, like XML, we tend to ignore fields you don't understand. The nice thing about the structure, it accomplishes two things we're looking for, particularly with outpace. One is, we go to businesses, one of the things we talk about is how easy is it for your business to run a business experiment? How hard is it to try a new algorithm in your business? Most establishments, especially ones with Stonehenges, it's a 6-month sort of discussion. You want to do this, you got to really want to do this, you better prove that you need to do this, because opening the code of making this change is very expensive. We want to change the arithmetic. We want to change the balance of that equation. We want to make it very, very easy for people to go in there and change something and see what happens. They only change it for part of the enterprise. We can bring up a new version of this purple service with a slightly different algorithm, publishing slightly different solutions, and see what the impact is. I don't have to touch this service. I don't have to touch the old purple service. I don't have to touch the green service. I can just deploy that. And it's easy for me to turn it off. It turns out to be a bad idea. It's easy for me to turn the old one off. It turns out the new one's a better idea. And this can happen very quickly. This gives the ability for a business to run those business experiments. In the States, we call this sort of the Capital One experience. Those not familiar with Capital One, the credit card company, they're masters at credit card experiments. They have a whole team that experiments with credit cards. So they'll try something. They were the ones that first got into giving credit cards to specific university graduates. So I could get myself an alumni card from my alma mater that has the card on there, and they worked a deal with the university, so they put the university logo on that, and I get carried around and say, look, I graduated from this school. And it turns out that because I graduated from that school, I'm actually, on average, a better credit rating than the average person on the street. So finding me and identifying me is a good idea. They ran this experiment. Turns out it makes good money. They started having a relationship with all the schools. They've actually experimented on things like, what color envelope do I send you a credit card offer in? Brown, green, white? They run those experiments. And they're constantly being best in industry because they have the ability to change their system so fast to adapt to this sort of thing. We want to provide that capability to all the businesses. And this architecture helps support that. The other thing is I want to be able to degrade gracefully. I don't want to worry about this system having to be perfect in order to run. If for something, your screen service all of a sudden blows up, I still get things to put in front of the customer. I like that ability. Now, when the green things goes down, I want heartbeats are going to the bus as well. And if those heartbeats don't show up, I know something's wrong. I go fix it. But meanwhile, the system is still working in a slightly degraded fashion. I like that. Now, I'm wrestling right now with some enterprise architects and a client who want to have this deployment system. I got to integrate it here, and then I'm going to have the other system that I actually put the real code on once you show me it all works. It's like, we got external services we're using. You can never prove that. And so I actually don't mind a direct deployment because I can monitor. I have the code in place that monitors this system, how well it's working. That's kind of built into this architecture. So So it's service taxonomy. This particular client we're working with, again, very much like the Chinese bank, we have lots of different channels people can come in on. They can come to a desk to talk to a real person. They have call centers. We have websites. We have iPhone apps. So lots of different ways to find out about customers. We think we're going to process the needs in sort of 4 broad categories. We have the concept of enrichment services. These are services that once they recognize who you are, have additional information they think is significant they want to publish into the bus. That may influence the sort of needs, satisfying your needs. Like I may realize that you are a frequent user of our services. Therefore, I want to give you a better offer. Or perhaps I recognize that you always buy, tennis shoes of a certain nature. I don't need to give a discount on those because you buy them anyway. Maybe I should get you to buy something else that matches the shoes. And so that sort of thing. But enrichment services, solution services, publishing ideas of solutions, any sort of biases we find associated with clients, their buying patterns and whatever that would bias us one way or the other to favor one sort of solution versus another. And there is a concept of solution blockers. The case of the shoes being an example. If I find out in the history that you've been buying these New Balance black sneakers with Velcro ties like I like to wear, if I buy them all the time, make sure you never, even though this guy may say, here's a discount coupon for New Balance shoes, this guy would say, he buys New Balance anyway. Block that. Let him buy socks for a change, because we know he's going to buy that anyway. There's no reason to give that profit back to him. So we have different types of services running and competing. And finally, all these things will be pumped over to somebody selecting a solution and handing it back to the client interface. Again, the way it's represented to the client depends upon the client's coming in. If it's iOS, maybe put an interstitial page. If it's the call center software, little green lights popping up on her station. But that's all that's very UI dependent. So, if I had a client, that information will be broadcast to all these services. The client might have more information published about it, so it'll get enriched and published back into the system. Could get enriched again, perhaps, based on that, but hopefully that's an exception. These guys will publish solutions and solution blockers. Solution will be picked by this service and handed back to the user. And of course, there's logging and monitoring going on all the time. So all this messages are being monitored for this. And I have a little animation that sort of brings this to light a little bit better. And then at that point, I can take some questions. So I've got a slightly better presentation for showing this. So this little animation is based upon a fictitious client who's a car rental agency. So a car rental agency has a rental car site, legacy website. So we sort of start at that point with our system. And first of all, when somebody actually logs into our site, or actually even shows up on our site and brings that page up, we want to put some very specific information on that page for that person as we can figure it out. So we plan to sort of put a hook into the web page so that we know about this. We'll write a little JavaScript, inject it into the page, and we'll get notified about that. And we're going to publish that on our high-capacity bus. So we'll publish that information on the bus. We got some offers up here associated that we'll give back to them based upon their location. So knowing where they want to go or where they're at right now, we might be able to give them very specific information. If we know they're sitting at the Newark Airport in New Jersey, we may want to say, oh yes, and here's an upgrade certificate for a car. We'd like to get you a bigger car, get a little more money out of you. By the way, I got lots of these bigger cars on the lot. I'd love to get rid of them. So it's a net win for everybody. Or perhaps I just have some generalized offers about this. Weekend offers, 3 days for 2, whatever. I also have all sorts of information enrichment services here, guys that know more about you. So I understand if you're a member, I have information about your membership, if you have membership in our frequent renter club. I also have some segmentation information. So I've looked at our clients list. I know who our clients are. We've done some sophisticated segmentation analysis. Are you a weekend warrior? Do you go to resorts on weekends? Are you a guy that's a business traveler? Are you a person that rents a van for moving? I need to know that sort of information to make my offers tuned as well. Every one of these things has their own little database. In my world, either you have your own little database. If you share a database with somebody else, you're the same service, just 2 interfaces. So really, I want to segregate my data and tune it to that environment. That allows me to run my experiments much more aggressively. If I don't have to worry about migrating a large database to run an experiment, that's very powerful. If I have to do a migration script in order to try my next experiment, unlikely that's going to happen very fast. So isolate this data from each other. And by the way, I don't mind having the same data in multiple databases. any more than I don't mind copying and pasting code around here. By the way, if you think you only have one unified database for your establishment, they're lying to you. There's data replication everywhere. It's a nightmare if they have, and I'm saying, let's live with that. Let's don't try to necessarily fix that. So, a little animation here. So knowing that's basically, oh, no, I need to slide the projector even more. Or make it a little smaller. We'll just slide it. So we know that we preserved this page as a car rental coupon thing. So that will cause a message to get published. So we know that we have a client sitting in our website. So we'll publish that to the bus. All these guys listen to that. So these guys listen to that. They say, okay, well, if that's the case, since we have no other information, these guys don't care. They can't do anything because you haven't told me anything about who's on the web page. So they have no action of their own. So they decide, okay, make an offer. They push that offer to the bus. This guy says, I have an offer, push it to the bus. This guy's listening for those offers, pulls them off. He can then pull them off, and there, lo and behold, up pops 2 more offers on that web page through our JavaScript. Okay, now we know it's Sally. Sally's sitting at that station and logging in. Ah, we know it's Sally. That's interesting. So now we publish a different packet, a little richer packet. It's got a little more data in it. That's why it's dark. And of course, everybody cares about that. So it goes to everybody. And all this stuff's running in parallel, of course. So we get 2 more offers coming down from that. New offers, because we know it's Sally, and Sally, knowing something about Sally is cool. But we also know that Sally is a member of our frequent guest program. So the enrichment services gets that stuff, pumps that in there. Of course, these guys care about that. Oh, Sally is a gold member in our club. Therefore, we should try this offer, which is only good for gold people. So we'll start pumping new offers out, which will get collected again by the same offer service. So now we got 4 offers to choose from. But of course, the segmentation hasn't run yet. We haven't realized that Sally's actually a road warrior. She's on the road all the time for business. So that goes up to these guys. Oh, Sally's a business traveler. In that case, let's make sure we give her some other offer associated with getting a bigger car or a built-in navigator or some other offer like that. Let's publish that out there. And of course, now that each one gets its corresponding message because each one is that way. So they add their corresponding other information to it, publish that to the bus. Now you see why I have a 250,000 message bus. And they get published and collected out of that. Now at this point, at that point we had some timers kicked off, we're ready to push to the page or some other thing has happened. And basically what we'll do is we'll go through and filter out these services and find out which ones are actually interesting. We selected those 3 of the interesting ones, we publish those off, and off they go. So we did some estimate and quick calculations. Oh, by the way, now that Sally says, I want to go to Houston, of course, it's all going to start all over again. Oh, Houston. In that case, if you're going to Houston, I get really excited by that. And if I'm New York City, I care less about this. And that sort of thing happens. So this is the message bus in action, very small services, cooperating system, lots and lots of messages flowing through the system. We're expecting for every web page we bring up, we'll probably push between 50 and 150 messages through the message bus per web page we show. So we're really going to push the traffic hard on that system. That's an example of the animation in action. Yes?
I understand that all the framework has trouble with. So segmentation and membership part can provide their information at different times. How does this location and round of those parts know when to pick a data and how to combine information?
Basically, from this web page, once they say it's Houston, I'll put a different information packet up here that says, I know it's Sally, and I know she's interested in Houston. So that'll be the new packet, I'll throw it up there, and all the same balls start floating around again.
Yeah, but in the previous animation, you have shown us how gradually the offer got improved by providing more and more information.
Right.
From membership and segmentation part.
Absolutely.
Yeah, so it appears that whenever any of these inboxes or provide new information, the location and round of response. Is that the case?
Well, sometimes it chooses not to respond. It's perfectly okay as a service decide not to respond at all.
Okay.
I mean, you tell me it's, I don't know who's at the web page and I'm the Newark airport, it's like, I don't have anything to tell you. You tell me you're Sally and I'm the Newark airport, I still have nothing to tell you. You tell me you're Sally, you're coming to New York City, now I'm interested in telling you something. But that's, every independent service can make those decisions on their own. But there's nobody here saying, oh, everybody has to respond or I'm not going to put it up. We're asynchronous. I don't want to put those bindings and ties in there. If you want to publish 5 offers, that's fine. If you want to publish 0 offers, that's also fine. If you're down, it's not fine, but I don't mind you being down either. It just says Sally's not going to get an offer from you right now. And when you come back up, it's too late to give to Sally. Don't worry about it. But if Joe comes along, worry about Joe.
Yeah, but you know, before I thought that once, let's say, location offers responded with the first offer, may think that, well, he's done the job.
Actually, I'd rather he not remember at all that he's ever heard about this again. Every time he gets one, I don't mind if he republishes the same offer again. I got the capacity for it. This guy will filter them out. He'll let the blockers block their offers they needs to block. He'll take the 15% offer and the 20% offer and make it only show one of those two. That sort of behavior is happening in that. Then he'll probably sort them all in some order based upon what he thinks you may want, based upon what the profitability will be for the company. Whatever the criteria is for the stakeholder, he can sort them out and show them accordingly. We even like the idea that, of course, this is a very simplified view. We're going to have probably 50 to 100 services doing this in parallel. But we have services that show, oh, I just showed you E before. I showed you E 4 times. You've still never clicked on it. I'm going to start degrading the value of E. Because for you, it doesn't seem to have an appeal. So I'm keeping track of that. There's another service watching that, publishing a blocker that says reduce the value of E because you showed E to this guy 5 times. E's not a very interesting thing to show him anymore. And the longer you stay on the site, therefore, you should get different offers than this. We'll probably even do a little randomizing. It says if this is E, F, and G, and these 5 are the best offers, we'll do a little bit of bidding about who actually gets it. But you know, we'll give some bias to the first guy on the list, but he may not get shown at all. We want to make sure we rotate around some of these others. There's also a concept for some new offers that you don't really know what their value is. We just need to feather some of those in periodically just to make sure that we can assess what their value is. We find that offer X is really valuable, but we haven't got any history with it yet. So we need to be able to feather those in as well. So there's a lot more things going on here. But it's all going on through a message bus. It's easy to break it down into small pieces. And I can turn my programming pairs loose on all this stuff, and they knock out a service or two a day at the pace. Because servers are not very complicated. That kind of concludes the presentation. So I try to leave at least a little bit for questions. I got 20 minutes for questions. Yes?
How do you deal with kind of stateful and transactional, sort of larger operations across service boundaries?
The question is, how do I handle transactional issues across these boundaries? So far, we haven't run across any of those things.
Well, something like, say, in this example, Sally wants to book a car, so you have to allocate a car to her, and you have to bill her, and you have to do all of those things, and they have to make it like a complete operation. So have you arranged it such that that's just not transactional, that car booking is completely independent of payment?
It turns out that's one of the problems we're not having to solve with this customer. They're happy with their current booking system. No, not yet, not yet. We did have wrestled that problem with Uswitch because we're obviously doing transactional work there. So but those were services that are running in a particular sequence. So if you didn't get to the end of the sequence, we would then put the whole packet together, submit it, and we can run that as a transaction. If it didn't work as a transaction, we resubmit it. But when you're doing energy change, for example, I got to make sure your credit card's valid, all those other things are valid, and the energy company will take your submission, that it's all in the right formats, and all that stuff happens offline. Some of those do fail occasionally in batch processing mode. We have to roll. That's all rollback, but that's handled by traditional transaction backend transactional systems. Most of the time, we're seeing that a lot of these services live very nicely with key value stores. Some of the services like segmentation tends to work a little better with relational databases, but every service kind of has its own database needs, and we're choosing the appropriate technologies. I saw another hand. Yes, sir.
Can you imagine having 200 or more of these little services, or what amount is it?
Well, I think in 4 we had 500 of these running in parallel.
Okay, now comes someone with a change request, and you have to figure out where to put the functionality. I think the basis is probably your data segregation, so it's this data, so it should be probably around this service. But when it's more not that easy to see, how do you find where to put it?
So the question is, when I have 500 services, how do I know what service needs to be changed when a new change request comes in? Well, it turns out if every service is doing a job, and it's the only service doing that job, it's not that hard to find them. And what happens is there is a team associated with working with the system, and the change request comes into them. And across those 4 or 5 guys working in the system, they have a pretty good idea where this functionality goes. We never actually write down any documentation associated with these 500 services. There's no written documentation for them. You only have to write this is kind of my Agile, I'm moving my Agile speech, but in my Agile world, I don't worry about documentation until that team itself needs to go somewhere else. If we're going to mothball the project, or I'm going to send this project to an offshore vendor, that's the time I got to document the system. But otherwise, the knowledge about how to change the system is sitting in the same room with the programmers. And they've shown no problem with working with 500 services. I had exactly the same conversation with Martin Fowler about 2 years ago. When I said, Martin, I have this very strange thing happening at Forum. We got these little, we got 150 services running at the time, all running at the same time. And he says, well, that can't work. And I say, I agree, it can't work, but it's working. He says, Fred, you should talk about this, which is why I'm here. Because in fact, it was working. So far, it hadn't been a problem. And I'm as probably as surprised as you were about it. Yes, sir?
Seems to me that there has to be a certain consensus on some areas, especially on data, because you can't talk about things if you don't have a common understanding of data.
Yeah, the common understanding around data is basically the message formats on the bus. We have to agree upon those.
I think more than that. I mean, you need to understand, if somebody, location, what is the meaning of location?
Yes.
There is a, you have to have some kind of a data dictionary, even if it's not written down.
Absolutely. I think that's the part of the stuff we're going to probably put into its own little package, so that we have those sort of definitions in place, and we make a common place of changes. Whether it's, you go to in terms of locations, airports in particular, they all have their airport codes, and you look those up. That's already standardized, so you want to use standardized feeds where you have it, but you have to create your own sometimes, yes. You have to worry about a little bit the sort of Babel problem you will create that says, I call Houston this way, you call Houston this way, you spell it differently, therefore we don't have a match. That's the thing that does concern me most about JSON strings is they're strings. And strings can be misspelled, and misspellings are not caught very well by systems. But that's the dependency we have here. But that's our point of coupling, is in that format, and the dictionaries associated with that. Yes, sir?
Yes, see, if you've gone from a larger service into a smaller service, you've spread out the database. Are there any issues related to data consistency or staleness? Seeing as if they're in the same database, you can get data consistency just from referential integrity. But if you split them out, then you may have the same thing.
Yeah, but my experience about referential integrity on databases is it's always fiction anyway. Yes, within one database is consistent, but then this other database feeds it, and these feeds come every night, so it's not quite consistent. So we take that into consideration about when these guys get their databases refreshed. In most cases, relative to segmentation, I'll probably resegment people, run segmentation once a quarter to build new concepts of what the segment should be. I'd probably classify everybody into a new segment 2 or 3 times a week, if not daily. So I'll classify you. If all of a sudden you're renting all like crazy, I'm going to move you into the frequent renter program. I'll reclassify you individually. I won't run the segmentation again, but I'll reclassify you relative to the segmentation. We think that may be something we run every day. Membership, if you join and I'm a day late knowing about it, it just means I may not have an offer to you that's very membership related at the point in time. Doesn't really bother me. Business isn't bothered particularly by that sort of staleness of data. I think there's really nothing in this particular system we're doing for this client that can work. We work with a day-old data. It's not going to be a big deal. If it turns out 2 days old, it's still not a big deal. Yes, we're not quite giving you the best service we might be able to give you, but in terms of giving you better offers here than what you're getting with nothing, we're way ahead of nothing. But it's something you want to read on a service-by-service basis. Yes, sir. So the question is, some of these services might be useful in some more different transactional systems. We, in fact, are going to do, so the answer is the service is available to anybody who wants it. It has a RESTful interface on it. You can query it whenever you want to. So we have that in there. And there's two reasons we have that. First of all, I'm not sending all the creative information associated with E through that bus. I'm only saying there's E, there's an out there, there's an E, there's an ID associated with E. We think E is the best offer for you. But the creatives associated with that offer are sliding somewhere else. And in that packet, in that message, is a URL to go get that information, a RESTful URL to go fetch that for you. So we carry around pointers back to the original data when you need to pull it down. We do the same thing in the Chinese system with the, or the medical system. We never send you the x-ray, but we'll send you a link to the x-ray as a message so you can go get it directly. We don't want that message information flowing through the bus. So the same way as these same interfaces exist on this for third parties. And we're looking at using outbound email campaigns, which is a batch process to some degree. Here's a million customers. Here's dozens and dozens of different types of offers. What's the best match for these? We don't want to send too many of these coupons out because it's going to cost us too much. So there's constraints over here, and we don't want to spam you, so we can't send you but one message every few weeks. So we have those sort of constraints, and we're going to use the same services in a batch mode to help us resolve that stuff. So yes, it is an entity. It has a job. It has knowledge of a certain entity, and we don't mind calling that from a batch service as well. Absolutely, absolutely. I think for the purposes of this, the more interesting part is the pull, because it's more fun to see the little balls dancing around. But yes, there's use of this without using the little balls dancing around. Yes, sir?
A lot of this sounds quite greenfield. Have you been through this with a brownfield implementation, like pulling current processes apart to turn into this?
The question is, have I done this in brownfield? To some degree, the work I did in the car manufacturer was brownfield. Because they had legacy databases, a legacy system, and we had to tie that into that. And the way we did that was just logically segregate the database itself and the processes they had. And we built a side stream process ourselves to hook. It came off their beginning of their system, hooked back into the end of the system, but it was otherwise independent. And that's a technique I've used quite a bit in my development with large gray field systems because of that. But that's the only experience we had so far in that environment. Now, obviously, they have a legacy websites that we're hooking into, but our hook is a JavaScript hook, and if you do click on the ad, I'm going to go to the same place you used to click on for the ad. So it goes back into the legacy system and makes a reservation or whatever for you. So I hook into that way, but otherwise, yeah, I'm kind of greenfield outside of that. So no real experience in that. I've been pretty successful in my consulting career avoiding trying to open up old legacy code. That's the type of project I tend to walk away from as well because they're not as much fun, and that's probably also why I've had a lot of my things rejected. So, other questions? Yes, sir.
This sort of encapsulation of data through services is great until your MIS or data warehouse guys come along and say we would support on this, and then we could completely skip your encapsulation and go straight to the database and lose all these benefits of data hiding all this way around this and this kind of.
Well, to some reasons, one of the things I'm hooking data warehouse is really a pond in my world, right? It's a static representation of information that you've had in the past. And basically the way I feed a pond is I just hook a process here that pulls these messages out and sends them to the pond. So when you actually click on an offer, I get that offer first. I put a message on the bus saying the offer was chosen. I actually put a message on the bus when the offer is shown. If I show you the offer, I'm going to record that. It's an interesting event. If you clicked on it, it's a really interesting event. You may actually eventually buy the service. Whenever that happens in the legacy system, I want to know about that as well. Those are all messages on the bus. Now, I will put the process here to pull those off and pump them into the data warehouse whenever it wants to be pumped into. So I interface the data warehouse out of this as well, but I treat it as a pond. I like data warehouses and the reporting capability of the data warehouse, but it is a sort of, not my operational store. My operational store has now become an event bus, not a database. And the supporting systems right now tend to be relatively stable little pieces. Again, refresh once a day. It seems to be enough for these guys. But this is the operational system. It's an event bus, not a database. Now the reporting stuff, the traditional reporting database, still a pond, still relational, still like that technology. Now that doesn't mean the data warehouse guys are happy with me. Because they wanted to have sequel to sequel, but it's like, you know, this is the world, this is my world, dude. So get over it. If we make the client lots of money like we plan to make it, the IT guys will have to live with it. Other questions? Yes, sir.
What are the typical hardware requirements for the ops?
I'm not a really good ops guy, so but we did price out for this client what it would take to run this system in Amazon. We're talking about probably 100 services, including a pretty hefty service to run the message bus. We priced that out. Most of the time we run I guess the small M1 smalls on Amazon. So it costs you about $40 a month to run a small M1. So each one of these little services, 100 services, are probably running on M1 small at about $40 a month. This was probably running on something running a couple $100 a month. It could run several thousand if we really pump it hard. Overall, we priced the system out to take about $250,000 a year to run the system in Amazon. If we priced it out with some private cloud hardware, we wound up picking up 4 pretty hefty boxes that we run the virtual machines in. And with some 50 megabit backplane stuff and the like, I think that equipment priced out a little more, about $350,000, I think, for private cloud equipment, 2-year lease, doing the system. We did price it out trying to run it on the client's hardware, and they came back with numbers that were 5 to 10 times bigger than that. But of course, they're used to what's a microservice? It looks like a big Java virtual machine. I run Stonehenges on these things, right? So they were giving me 50 Stonehenge machines. It's like, no, I don't need 50 Stonehenge machines. I need this little guy, one core, a few mega RAM. That's all I need. But obviously, they're not tuned to build microservice systems. I think one of the things that enables this is, in fact, we are in the cloud now. I mean, this size of application we're talking about writing right now is the size I was writing in the 70s. A couple hundred lines of code, 1,000 lines of code, running on my machine. That's the size of application we're writing. Now with the cloud and how easy it is to get a cloud virtual machine, we're almost going back to writing code back in that style, which I kind of find interesting because that style was kind of fun. It also means I'm probably talking directly to the customer. I really understand the business. I don't have these layers of BAs and specs and everything between me and the customer. I'm very reactive. I respond in days, not months. It's a lot more fun in this environment. Yes, sir?
Just to follow up to your previous comment, if say you worked in an environment that was very committed to Java and JVM, have you come across particular technologies in that space that would help you with these things?
There's nothing that says this can't be written in Java. Because it'd be a little wordier, but architecture still fits in Java. In fact, Jeff Bay, I've hired Jeff Bay, obviously, into my group because Jeff Bay does amazing things. And Jeff Bay is looking forward to Java 8. He thinks Java 8 is just like the perfect language for this environment. Because it's functional, very functional programming, all the functional constructs in there, the declarations have melted away. He can write gorgeous code, he thinks, in Java 8. He can write it either in a functional style or he can write it in an object style. So, yeah, it's kind of, as the comment says, it's like Scala. Hopefully it's not that but it could be like Scala. I'm not convinced, but Jeff Bay tends to have a history of being correct in these things. So yeah, this could be done all in Java. I mean, I think the Kafka bus is written in Scala, actually. Just to give you an idea of technology stacks. We're using Event Machine and ZeroMQ, so we're using Ruby Event Machine with ZeroMQ. So it's a very hybrid. We'll probably write the guy who sorts out the offers, we'll probably write that in Clojure. Because that's really good for just taking lists of things and figuring out what should fit and not fit. So it's a very list-oriented sort of process. But yeah, you can do all this stuff in Java. And if the client requests us, recast the stuff in Java for their own use, we would do that.
What kind of repository are you using? Because I imagine that it's quite important to keep track of what each service is doing so that you don't replicate it 100 times.
No, not important. Of course, it's important to keep track of what every service is doing. We're probably it's maybe your question. We don't have that problem. We didn't have that problem in Forward. We had 500 of these services running. We don't mind multiple versions of them running. So, But again, if a service is running and nobody's using it, it turns out for $40 a month or less, it's why even bother looking for them? The programmer, how much they have to pay you to go find one of these guys, it's not worth even looking for them. And again, they're very cohesive. Every service does its job well. So if you sit down and start writing a new service and you're not talking to your colleagues, you may actually write a service that already exists. Well, we'll have 2 versions of it, fine. Yes, sir?
What happens in 10 years when you've got 4,000 dead services?
Don't know. Ask me in 10 years. I didn't think I could get past 30 or 40 services before I had a problem. And we're sitting at 500, not a problem. So my guesses are all crap. So maybe 4,000 is not a problem either. I've certainly written object-oriented systems with 4,000 moving parts and never had any part of that. Yeah.
One's fine. It's just when the number of dead ones starts to totally overwhelm the number of live parts, and you have to track them. I suspect just by looking at how much the CPU is being used and from Google reports, I'll find out which ones are going to be turned off. And if I turn them off and my metrics go to hell, it's because I turned off something I'm using. Whoops, let's turn it back on again. So you can just try to flip on-off switch. I suspect by the time the problem arises, Google has some really good tools for finding that for us. Yes, sir? Don't care about service repositories. All that tracking of services and all that stuff that we talked about thought was very important to keep them tracking at an enterprise level. Don't believe in any of that anymore. Not a believer anymore. Again, I'm very pragmatic about this stuff, and the time may come I think it's important, but the time I thought it was important has already passed, and it hasn't been important yet. So I'm giving up on it.
How do you manage the SLAs between services? Is this always interaction?
Question, how do you manage the SLAs? Well, remember that if you may be the programmer writing both sides of the code. So it's your SLA to worry about. So I think a little bit it comes to the data dictionary talked about, that it is important to sort of keep track of, at least register, this is what our packet format looks like. These are the possible values for a location field. That sort of information we need to write down. Or at least have some place you can refer to it. Actually, it'll probably turn it into code. We'll probably turn it into JSON structure that we'll maintain so people can read it in dynamically and pull it from it. But we'll just put a JSON structure in place that keeps a sort of dictionary of all those things in our minds. Those are the things we need to agree upon as the packet stuff. But if you write a service and it doesn't work when you put it on the bus, and by the way, right now we're running this bus on I run this bus right now on my MacBook Air. So I can bring up everything you talked about here, I can run on my MacBook Air, including the Kafka bus. So I can test everything on my workstation and see how it works. We tend to err on the side of technology we can use like this. Now this is not a small machine. It's got a half a terabyte of solid state drive. It can push some data around. But it's still a 2-pound laptop running all this code.
So do you not define SLAs and store for each of those services? Because obviously the web server compares to
Nope. Basically, every one of these guys can set their own timeouts based on what sort of client you're interfacing to. You're interfacing to an iOS app. Have you got WebSockets available to you or not? All that's very client dependent. So basically, that's code here that decides how long do I want to wait before I push out my answer. And it may be right now we think 300 milliseconds. I'll push out my answer at 300 milliseconds after the page comes up. So we know as soon as the page gets loaded, you're there. Well, we have 300 milliseconds to get our best offer together to push back out to you. And we'll stop at that point and push it. But we still accumulate the offers. When you do a page refresh, I know it's still you. I'll have a better set of offers the next time on the next page refresh. So I'll keep a little cache of that stuff running, and we run that in Redis. We'll keep that running for at least 10 or 15, 20 minutes after we've heard from you the last time, and then we'll purge it and start over again. But otherwise, I'm accumulating the best offers for you. And whatever a timeout agreement is, we just set that timer and just kick off on it.
Have you been forced to do any major releases since you started this process, or has the evolutionary approach worked all the way through?
Well, again, in Outpace, we're just starting this part out, so I can't talk about that because we haven't deployed the system yet. We're still developing it. In Forward, though, we had a system that continually ran for 3 years. At the point I left, it's still running. And there's no concept of a real release. Remember, I'm putting microservices. It's really tiny incremental changes. It's nothing that would be, quote, a big release of anything. Big release may be something that takes a week to write. I mean, that's huge in that world. But it's a whole different scale of thinking. But it's like the human body. It's a living system, organism. It's not like it's going through these major transformations. It's not a caterpillar going to a butterfly. It's always a little incremental changes.
You may have heart surgery, right?
Yeah, hopefully not. I'm definitely out of time. You've been a really attentive audience, so I appreciate you hanging around. Enjoy your lunch. I'm around for the next couple of days. Please find me and talk about this stuff. I love to talk about this stuff if you can't tell. So, thank you very much.